let's go for problem G. So this problem needs some facts to solve. First of all, when n goes up, finally, sometimes it's impossible to find the answer why. So let me tell you that it says that you have a permutation, right? So the minimum sum you can find is, let's say 1, because you can put the 1 in the middle, no problem. And the maximum number you can make is 2 times n minus 1, let's say 2 times n. And you want to find n divided by 2 number of primes in this range, right? So it's like this, 1/4. And you should know that when n gets large, we can say number of primes divided by n, number of primes less than or equal to n, divided by n, limits to this limit when n goes to infinity is 1 divided by log n. So for sure you can understand from this that when n gets large, this fraction gets smaller and smaller, and 1/4 is a very big one. And in practice you can see number of primes less than or equal to 0 is just 25. So when n is 50, for sure we can't find the answer, right? Because out of total number, out of numbers we have, we don't have enough prime numbers to show. So let's go for this and find the solution for the small n's. And for the rest, answer is -1 for sure. That's it. Okay. So this was the beginning. Actually, in order not to miss, maybe for n equals to 50, we can find the answer. No, for sure. N equals to 50, for sure answer is -1. So that's it. So consider some n, and we want to find some solution, right? So we need to find n divided by 2 pairs like a, b, such that a plus b is prime, right? So what we understand here is at least one of a or b, and let's say like this: a is even and b is odd, or vice versa, or one of them is 1. 1 is an exception. So it never happens that 2 even numbers or 2 odd numbers result in a prime. It can't happen because the resultant number will be even and it's not prime. So I know that you didn't expect this, but make a bipartite graph, even numbers and odd numbers, and we want to find the perfect matching. So if we don't have this condition, I mean, if we don't know that when a plus b is prime, one of them is odd and one of them is even, we might think that this problem is about a perfect matching in a simple graph, not bipartite. But given this fact, we know that it's also bipartite graph, and that's it. So this is a simple perfect bipartite matching problem, and we are going to solve it. So I will start this copying my matching code from here. Then let's open up CLion and do the rest. Actually, we could solve this problem using Python too, but yeah, I have matching code in C++, so let's do it in C++. First, let's make this code a bit cleaner. And okay, that works. So it's a very simple code to find the maximum matching. Nothing special. Let's loop over n from 1 to the max n and solve the problem for each of them. Build gg plus n, an empty vector, then let's make the x is prime and x for each p is 2, and if this return false, return true. If it's prime, I will put an edge from I to j, and okay, if maximum matching of n is scale of n divided by 2, we can say that we found a perfect matching. So if you don't know perfect matching or bipartite graph, any of them, search for them, read about them in CP algorithm, and yeah, reset complete. And if we found that, let's have this, or simply okay, goal solved. Okay, then we can say solved n is true, and then make a for loop over 1 to n, but I plus equals 2. Then we can say that cer means the certificate, so it's the certificate that how we solved this n. So this is gonna be I, and in the vice versa, the opposite actually, index we put its matching of I and 0, and yeah, that's it. Finally, we get queries, and we get input if solved n, if n is less than max n, and solved n, count yes, and else count no, or no, count -1. Yeah, look over I 0, I is less than n, plus I, just print, that's it. And it was autocompleting, go ahead. Okay, and the line, that's it. One, 2, and -1. Why? 3 has answer actually. Let me check out if it's finding answer for others or no. Can you please return array solve? Yeah, it hasn't answered for odd numbers, but let's see why. Aha. And the pushback one, it's an exception actually. What? Same thing happens. So like one is connected to one. So why actually I believe I should add one to this. Aha. So it should go in exact. Okay, 1 to 1. Okay. Let's say if n is the thing is I'm putting 1 in a right position. Okay, let's think about what we can do here. It should be something like this, but I'm not sure. I need to fix these formulas. Wait a moment. So I start from 1 and L from n minus 1 divided by 2 or n divided by 2 minus L plus R, and here I put this here, I put this here, and let's see the result. Okay, 3, 1, 2, and just for checking, it seems like working. Let's submit. Problem G. Okay. Problem G submitted. Problem G running. Okay, still running. Let me see if I can make this code cleaner while it's thinking. I was thinking of we can make the graph outside. What do you think? So, oops, we got wrong answer. 23, 549, and what else? Well, let me try 50. Really? Let me try 99. Okay, so I got that this code is working correct. 99 plus 92. Are you sure? Okay, let's go even more. 199 plus 98, but was it's really prime. 199 itself. Okay, so where I was ranked. So do we have 50 primes in range of 1 to no, do we have 100 primes in range from 1 to oh, it's possible that primes are not unique. Okay, I was wrong. So what we understood was what I was doing was wrong, because primes, they don't have to be unique. So I tried a new method. Let's show you here. I will try to reduce the problem for n to some smaller n. Let's say parent of n. Then consider we solve the problem for parent of n. That parent of n and n have the same parity. So if the problem is already solved for parent of n, then I can put the numbers after parent of n to n around this permutation that created, and make sure all of these elements, all of these pairs are resulting in primes. I can make sure that we found answer for this n2. So I was printing parent for some integers. Let's say like for 10, its parent is it prints actually the parent plus 1. It prints 9. So it means that we can solve the problem for 8, and then we can put 9 and 10. You know, 9 plus 10, it's prime. So it works. So that is what I'm gonna do now, and let's see what happens. First, I need to modify my is prime, because it won't work if I continue with that. I is, let's start with 2, go to max 10 plus plus p, then go over I, which is p times 2, then I is like this, and set is prime is false, and then fill n is prime, max n and true. So now let's start for every n from 3, because 1 and 2, they are the base cases, right? N to max n, which is good. Let's find its parent. Here I put parent of n to be I minus 1, and then break, and here I say this parent of max n, and here we need to specify something else to start from, like L. And if I was able to do so, we will break here, and also make sure that we are resetting everything, which is very important. Like an empty vector here. Okay, using this code, I will find parent of all of the numbers. And for instance, let's print parent of 10 to make sure it's working and not taking so much time. Okay, is prime is not defined. Now I'm gonna define it like this. Okay. So let me reduce n by something to make sure everything is correct. Okay, good. follow this. Taking so much time. Let's think to see how we can solve it. Okay, I found the bug. So it was here, and as you can see, I'm filling all the big area of mark with 0, which for sure takes a lot of time. So let's do something about this, like this, and also I need to do the same for mat, fill mat, fill mat n plus 1 minus 1, and okay, now I'm finding parent of every integer, and also let's define max p, which is max n times 2, and define this max p, and do the same here. Okay, let's run. Okay, and I can easily run it with 1,000,002. Yeah, it runs, and it's fast enough that can pass. I hope at least. So, finally, what we do is just print in, and then let me show you how I print n. Print n if n is 1, cout 1, return. If n is 2, cout. If n is 0, just return. Then I need to make some certificates here. Let's define vector prefix suffix. So as I said, we are gonna print something at the beginning, then we exactly print what our parent says, and then we print some suffix. So here that I found maximum matching, I'm gonna print all the certificate here, and how let's start by j, which is I, and j goes to n, and 1 by 1 if j is odd, go push prefix of n, the j, and go push here who matched this j at the opposite side, and finally we need to reverse ser suffix, and that's it. And that's it. Okay, let's try. 1, no, 5, 1, 2, 3, 4, 5. Just 1. Oh, I missed to forget this. I missed to fill this function for every x. Insert prefix goes out x in space, then print parent of n. Here I need to start from 2. Then do the same for ser suffix. That's it. And finally print and l. Let's see. Looks good. I hope that it doesn't take more than 1 second, but I'm not sure. Let's see. While it's going, let me calculate how much time it takes to finish this. Okay. Okay, we got DLA. Oops. Okay, actually it's also considerable. So let's do something for it. Okay. It should be much faster now. Not that much, but it's faster. Let's put it here. And then compile. Then let's see. It's still taking a lot of time. Let me see how much time this is consuming. It's also considerable, but yeah. Okay, let me try to fix the issue and I will be back. Okay, my idea is to move this part for calculating the parent to the print function itself. So let's see if it's gonna work. So if n is -1, let's calculate it. So it goes and tries to calculate the parent of n, and let's fill parents, fill are -1, sorry, and that's n and -1. We have some mistake here. This is 4, this is 8. Okay, let's run. 1, 2, 4. You should move it here and then run, and then let's submit. Okay, submitted. Let's see if we can make it even better. Like we can say, this is impossible to find maximum matching if there is a vertex that its size is, so it doesn't have, basically it doesn't have, okay, we get accepted.
Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.